Guys, how are you? This is going to be for day 6, which was Wednesday. I'm catching up as fast as I can. Like I said in my email, which I'm going to put out for y'all, I'm a little bit behind because I've been doing so much stuff. I'm just trying to catch up. So, and I see some of you are really up on board. It's hard for me to penalize you if I'm way behind. So I will be catching up this weekend, and I'm hoping that you will find time to catch up this weekend, and then we can start the ball rolling on Monday. All right, so first of all, the choice boards have kind of changed a little bit. So if you look on here, now what you're going to do is you had all these beautiful activities and the online things you had to do, but what you're just doing now is you're just pretty much doing these activities. I'm not making you watch anything else. It's hard enough for us to get on and to read and do our one-pager and our math problems, and for you to watch this video without me actually giving you something else. I will start probably next week sometime and give you some extra things online, maybe that can help you. You need to make sure that you get in on the textbook. Listen, I have sent some of you text messages. You said you can't get on. I gave you a way to get on, and then you have to get a passcode from me. So our goal this weekend, and hopefully by Monday, you'll get on so you can kind of catch up. And by the way, a big shout out to Mikhail for making the student senior of the week, I think is what it's called. And I really appreciate him mentioning me and telling me that he appreciates me, and that just makes me want to appreciate him even more. So, first things first, on our plan here, it says teach Chapter 8, Section 1, describe rotation motion, 204, 207, one-pager, and practice problems. So, what we're going to do is we're going to go through, and right now in my ISM book, I am on page 96. I don't really know where you are, but that's where I am. We are going to start our new book on Monday. And if you have to start your new book today, then that's fine too. But I am going to start doing my table of contents for my new book on Monday. So, here, what we have. We are talking about angular displacement. We are on page 204. And what I did is this is what my one-pager looks like. Your one-pager doesn't have to look like this either because it makes sense to me. It might be too much junk for you. So what it was telling us here is that a radian is 1/2 pi of a revolution. One complete revolution is 2 pi. Okay? And then you have what's called theta is another thing that's new this time. Counterclockwise is positive. Angular acceleration. Angular acceleration uses the change in angular velocity, which just looks like a fish a little bit. This kind of looks like a funny W, and the change in time required. Now, the reason why I'm having you do the one-pager for is so you can do this information so you'll have it here for your quizzes and tests. So the Earth. The Earth revolves one complete rotation, and it is called 2 pi rad, which equals 24 hours. 12 hours is just a pi rad. Then we have X equals R, which is in meters, and then angle. Gives us that funny looking W again, which is our angular velocity. See, it's the same thing. Equals the angular displacement over the time it takes for one complete rotation. So what it did here is it just basically kind of showed you how to do this with angular of the Earth. And it was telling us that, you know, the Earth rotates in one complete rotation 2 pi rad. And it divided it over 24 hours and 3,600 seconds, which gave us that number there. Looking for my calculator. There we are. So let's see if we can actually do this on our calculator. So, we erase everything. So we're going to do alpha, y, enter. We're going to do 2. Our pi key is our second with our little caret key. Rad is a unit, right? So we don't have to put that. And then down, open bracket 24, close bracket, open bracket 3600, close bracket, enter. And I got 7.27 times 10 to the 5th power. Fantastic. Kind of shows us how to do the equation. Kind of helps us out a little bit. We're good so far. Okay. The next one is actually where we're trying to find V. Okay. So if we're trying to find V, so we're going to do this one, which is very easy. 6.38 times 10 caret 6, close bracket, open bracket, 7.27 times 10 caret 5, close bracket, enter. Oh, look at me. I got to check and see what I'm doing first. Okay, so I'm going to bring it closer. I can see. 6.38 times 10 caret 6 over, I missed that, close bracket, open bracket, 7.27 times 10 caret 5 over, close bracket, enter, and I got 4.63 to the 12th power. Okay, and if I wanted to change this, then I could change my mode to normal. Well, guess what? When I change it, it gives me the same answer. So it's a really, really small number. Okay, so next thing we're going to do is we're going to go where we're having the problems at. Now remember, your textbook. You have your textbook, I understand, but you need to learn how to get on the digital textbook because that's going to help you out when I'm going to give you some equations or formulas on that. So the first one says, which is the angular displacement of each of the following hand clocks at 1 hour? State your answer in 3 sig figs. So, if we have 1 hour, how many minutes is in an hour? 60 minutes in 60 seconds in an hour. So, we do 60, negative 2 rad, that gives us the answer. Number B, 1 minute hand. Well, 2 rad is my answer, 2 pi r. And then for an hour, it would be 1 over 12, negative 2 pi r. Where did I get that from? Well, I went back here, and I used the little chart down here at the bottom for that. Okay? So, number 2, the rotation of a toy in the base crib, make a complete counterclockwise rotation in 1 minute. Okay? What is the angular displacement in 3 minutes? So what I'm going to do there is I'm just going to go through and I'm going to say, all right, 3 minutes times 2 pi rad over 1 minute, which is going to give me 6 rad. What toy angle velocity in rads? Well, we know that the toy's angular is 6 pi rad, and it's asking us for 3 minutes, which is 2 pi rad over minute. And then if the toy's turned off, does it have a positive or negative acceleration? Well, it's not moving, so it's trying to slow down. So guess what? It's a negative acceleration. Number 3, if a truck has a linear acceleration of 1.85 meters per second, that is my acceleration, and the wheels of the angular acceleration is 5.23 rads second squared. Well, that's my little fishy sign. What did we decide our little fishy sign was? Let's look over here. Our little fishy sign that we were using is angular acceleration. Listen, see what's so great about it? Your notes are here. I can actually do my math here. So then what you're going to do is it's asking us for number 3. It says, what is the diameter of the truck's wheel? So the only thing I'm going to do is I'm going to take A and divide it by the fish sign, which is going to give me 0.354 meters, and the dimensions is 0.707. Now remember, alpha, beta, and gamma. We've kind of done those Greek letters before, so maybe that'll help you remember that one. Number 4, a truck's previous problem is in towing a trailer with the wheels have a diameter of 48 centimeters. Change in the velocity will be the same, so the linear acceleration are the same. B, how is the angular acceleration of the truck and the trailer and the wheels of the truck compared? Well, the radius of the wheel is reduced to 3.54 to 24 centimeters on an angular acceleration, and it would increase. So we have our alpha 1, which is 5.3 rads S2, Then we have our alpha 2, which is A over R, which is acceleration over radius. So we're taking 1.85 divided by 0.4, and we get 7.7 rads divided by speed s squared. I'm not making you do the challenge problem. So, may I suggest to you every day, go through and read it. Write down your notes. Remember, the textbook reads to you if you want it read to you. I am going to go back and I'm going to have it read to me now that I've taken my notes. I have a problem with trying to read it, or better yet, listen and take notes then. I like to read myself, take my notes, and then use my notes to look back at the video. Guys, this is for day 6. I'm going to try to do day 7 and day 8 today, or at least in the morning. So, if you've already done the problems and I tell you, look at the video, that's what you're doing. You're looking at this so you can get some help. Because guess what? Based on our information and based on my little timeline here, and let's zoom it in. Well, better yet, let me get my little face off here. And let's zoom it in and let's see. Look, guys. So here, we're going to have a test on Tuesday. So here is Friday. Tomorrow we're going to do a new section on Monday, and then we're going to get a test on Tuesday, and then we're going on to a new section. I promise you that I will not fail you as long as you turn something in. I am giving you all the answers. Even if I want you to try first, and if you can't get it, good. Use my video and have it help you, okay, guys? I just want to let you know that I miss you, so much. I can't wait to get back to school, and I love you all. Y'all have a good weekend and be safe.